Hello, and welcome to another value transformation product development video. Today, we're going to talk about decision matrix. In the course of our product development activities, we're going to have to decide approaches and strategies and things like that, some of which will require on intuition and some hard data metrics that we may have, and sometimes it's a mashup of those things. Today, we're going to talk about non-weighted example of a decision matrix. If you're interested in weighted examples of decision matrix, please go to the Value Transformation blog. The story goes like this. We're ready to start a verification project. The project actually delivers a bunch of embedded parts, physical parts, electronic hardware, and what we call electronic control units or ECUs. A lot of software updates and a lot of hardware updates. Some of which will be tested at component level, some will be tested in hardware in the loop and things like that, and some will have to be tested on the vehicle for other testing objectives. We then figure a number of approaches. We say we know what's important. We know dependencies are important. We know that in order to test the product on the vehicle, you have to have the product and you have to have the vehicle. That's the dependency. Software has to be delivered, hardware has to be delivered, embedded hardware, and all that has to be available when the vehicle is available and the test guy's available, or gal, test personnel. So we know dependencies are important, cost is important, because that's business, and it's always important. Quality of the test, that is the repeatability, the ability to go back and rerun the test again and guarantee the veracity of the outcome if you run the same set of steps. Use of the time, that is the ability to start testing straight away, not having to troubleshoot a vehicle because it's a kludge of old parts, for example, and the ability to use the vehicle later. So we're going to compare each of our strategies. We say our strategies are here. We can get a new electronic engineering vehicle. We can use an old EE vehicle that we have. We can update any old vehicle. We can share a vehicle and new vehicle, and we can share an old vehicle. Okay, so for dependencies, if the EE group has the parts, the vehicle, whenever the parts come in, they're ready for test. So that's perfect control of the schedule. Doesn't matter if the software is late because the vehicle is still there static, ready for the test whenever the test is ready to be conducted, which is whenever the parts are available. We have old EE vehicle. Well, that's still contained, the EE department would still hold on to the vehicle. Therefore, the dependencies are met. That's another static vehicle. The vehicle is available whenever the test needs to be conducted. Any old vehicle update, any vehicle updated. In this case, we still have the vehicle in the EE group, but we're taking old vehicles and updating them. You still have the dependencies met here as well. Shared vehicle. Well, if you're sharing a vehicle, that means you can no longer secure the time when the vehicle would be available. If, for example, the test is to be conducted from week 3 to week 9, and the software arrives week 5, you've just lost 2 weeks of testing, or you're going to have to forego some part of the test that was planned. Not only that, if it's a shared vehicle, the people who have the vehicle before you are going to run some tests, and you're not sure the results of those tests on the vehicle. That is, they could be quasi-destructive, they could modify things that are not secured, engineers tinkering around, alter some part of the vehicle that matters. So this is not 100%. We're going to say this is 33. We know that sharing vehicles is very tough. And once you lose your place in the schedule because something's late, you can't really get the other end of the schedule back. They're usually booked end to end, or so experience suggests. So if we're sharing an old vehicle, we have that same problem. The dependencies cannot be met. Cannot be reliably met. Cost. Okay, well, now for a new EE vehicle, we know to secure a vehicle just for the electronics engineering, the costs are going to be kind of high. So it does not meet that attribute very well. But an old EE vehicle perhaps does. Minor, just a cost of updating it, and the vehicle's already depreciated. Old any vehicle updated. Same deal. It's depreciated to some degree, so we don't have to worry about that. New shared vehicle. Well, with shared vehicle cost. Now we're sharing the cost of the vehicle, which is probably not of a new vehicle, but it's probably not the same as a new vehicle straight up cost, but it's going to be more than nothing, or than the already depreciated vehicle cost. And an old shared vehicle. Well, that's a old shared vehicle update. Let's say that's 100 points. And that is because it's an old vehicle that's depreciated and we're sharing it. So any cost to update it would be spread amongst the groups that are using the vehicle. The quality of the test. Well, if it's a new EE vehicle, we know that the vehicle should have been built with the latest iteration of the parts. We have to tear it down and rebuild something to the new way of working. It's got new wire harnesses, it has new electronic control units on it, it's got new actuators, all the parts that should represent production. So the quality of the test, from that perspective, should be pretty high. Old EE vehicle, on the other hand, is not quite so blessed. The old EE vehicle has had old parts, and you have to make sure that you have got the correct parts for this production iteration, which means there's chance that you've used old parts that are no longer going to be in production on the new system. So we're going to say that's a 66, and the same with this one. And a new shared is going to be more like the new EE book there. And the old shared is going to be more like the quality of the test. This one's actually going to be a little worse, because in this case, we're sharing a vehicle, so we have people knocking around the truck or the car, making adaptations to run their tests, and we're not sure what they have done. So we have two problems here. We have an old vehicle that had old parts, as in an iteration of the design that is no longer going to be in production, and you have people knocking around the vehicle, perhaps making modifications to it, undocumented, that may impact the EE test, electrical engineering test. So we're going to say that's 33. Use of time. Well, if it's a new EE vehicle and it's been built with the manufacturing process like these are, then we're not in a position to have to go back and rework, gut the wire harness, reroute everything. It should be close to production parts, actually built off PPAP parts, or something pretty close to that. So that's going to be 100 points. In the old EE vehicle, the use of time is not so good, because we will have had to have torn down the old vehicle to some degree to rebuild it. Although it's one iteration back, so it's not altogether horrible. It gets worse when we look at the old any vehicle updated, because that's not a vehicle that's been under EE control. We don't really know the iteration or iterations of the vehicle content. That is, it might have a 2005 instrument cluster, a 1998 or 2002 ABS system, and things like that. So the use of time for any old vehicle is not going to be so good. Use of time for a new shared vehicle is a 100-pointer, because the only thing we're touching here is the fact that it's a shared vehicle. I'm sorry. The use of time on a new shared vehicle is slightly less. And that is because if you're sharing a vehicle, we're back to the old part where the people who are running the test before you can alter the vehicle before bringing it to you, before it's your turn to have the vehicle. And they may not document that. You may find that out in the test. So new shared vehicle has the problem of use of time in that they may alter the truck in some way that affects the EE tests without you knowing it. So when you run the test, you get a failure, then you find out that the design has been altered from production intent. The same is true for an old shared vehicle. Vehicle use later. Well, if none of the tests are destructive, and new EE vehicle can be used later. Old EE vehicle, none of the tests are destructive, but it is an iteration back. So any new builds from the old iteration have to be upgraded. That is, updated to reflect the latest production intent. So this is not quite perfect, but it's something like that, maybe. Old any vehicle updated. At some point, these vehicles are pretty worn and unable to go any further, so the use of vehicle later would steadily drop, and especially if it's not been in the hands of some department that has cared for it. New shared vehicle use later is 100 points as well, and old shared vehicle is going to be the same as old EE vehicle. Actually worse, because now we're talking about two things. We're talking about the depreciation of the vehicle and what has been altered by those who have used the vehicle. So actually this is not 100 either, it's probably like 66. Okay, now in real life I would not have done this by myself. There have been 2 or 3 other people with domain experience around the whiteboard. We'd have made this on the chart on the whiteboard and walked through it. But you can see, of all the alternatives we have available to us, new EE vehicle is the better of the solutions. At least the number of points awarded are the highest. But the close behind is the old EE vehicle. Decision matrix can help us understand what we need to do when we're not altogether sure. It gives us a chance to pause from the actual work and reflect on our experiences and what's important about what we're trying to accomplish, and then mapping our approach to best achieve that objective. Thank you for watching this value transformation video. If you have any questions, please contact us, john.quigley@valuetransform.com. Visit our website, www.valuetransform.com. Thank you very much. Have a great day.